Good morning, children. We were discussing fun with magnets, and in the previous class, we had just started with the properties of magnet, right? So we'll continue with the properties again today. Today we'll be discussing repulsion as a surest test for magnetism, and also the next property of magnetism or magnets, that is to find directions. So in our previous class, we have spoken about the property of attraction and repulsion. Now there we said that like poles repel and unlike poles attract. Okay, so if suppose we want to test whether a particular material is a magnet or not, so repulsion is the surest test. Why? Because attraction can be caused either by opposite poles of magnets or also between one pole of a magnet and any magnetic substance. Okay, so even if it's an unmagnetized bar of iron, that is also going to attract. So in both situations, it's going to attract. Whereas repulsion is going to happen only when there are two magnets of similar poles coming together. Okay. So we say that repulsion is the actual test to check whether the particular substance is a magnet or not. Okay, so that's what is shown over here in the figure also. You can see when we bring another magnet with the north pole towards the north pole of the suspended magnet, it repels. Okay, so suppose you bring in any magnetic substance also, it is going to attract. So attraction is not the surest test. The surest test is only repulsion. So now we move to the second property of magnetism, that is the directive property. Now, this property is proved when we suspend a magnet freely. Okay, so in this situation, what we see that the magnet directs itself to the north-south direction. Okay, that means the north pole of the magnet is aligned towards the geographical north pole, and the south pole is aligned towards the geographical south pole. Therefore, it helps us to see the direction, and that's the reason why it is termed as the directive property of a magnet. Now, as we saw that a magnet has directive property, it helps to show direction. This is related to the fact that Earth behaves as a huge magnet. Here you can see in this picture also over here that there are magnetic lines, okay, moving from the north pole to the south pole. Now here in the second picture, the lower picture, you can see that the geographic north pole is aligned with the magnetic south pole, right? And the geographic south pole is aligned with the magnetic north pole. This is the bar magnet in blue color. When N and S is mentioned in blue color, shows the huge bar magnet, okay, which is placed, you can say, upside down. That means south pole of the bar magnet is towards our geographical north pole, and that's the reason why why any bar magnet, when you suspend freely, it is the north pole of the bar magnet is attracted towards our geographic north, because in reality that particular point, that is the north pole, is having the magnetic south pole. Okay, that's the reason the bar magnet behaves in such a way and shows us direction. Now that's all for today. We continue in the next class.